Lesson 5-7, Graphing Inequalities in the Coordinate Plane. The big idea: the graph of a linear inequality in two variables consists of points on one side of a line, either with or without the line. You're going to remember this from Algebra 1 where we drew a line, okay? We drew a line and then we shaded, okay? Now we're going to get into a little bit different types problems, but it's going to be the general movement here. As you learned in Lesson 5-1, solutions to compound sentences with inequalities involving only one variable can be graphed on a number line. In this lesson, we review the graphs of inequalities in two variables. When a line is drawn in a plane, the line separates the plane into three distinct sets of points. Two regions called half planes. Okay, you got the top half, you got the bottom half. And the line itself. The line is called the boundary of the half planes. Okay? The boundary does not belong to either half plane. You need to remember that. Boundary does not belong to either half plane. What I also want you to remember is you have a dashed line. You graph a dashed line if your inequality is less than or greater than. You graph a solid line if you have less than is equal to or greater than or equal to. Okay? So inequalities with horizontal or vertical lines. As you can see here, we have a vertical line at 3. Okay? Now, it's at 3 because it goes right down through 3. We know that it is x equals 3, but we know it's an inequality because everything is shaded to the left side. So we know this is open, okay, because of the dashed line, so I know it's less than or greater than. So to determine if it's less than or greater than, since everything is shaded to the left, everything that way is less than. So you would call this x is less than 3. Okay. Let's look at example 1. Graph the linear inequality y is greater than a negative 1/2 x plus 2. Now you could probably type this on your Desmos and get your lines, which I might show you in a little bit. Or let's do that. Okay. Y is greater than a negative 1/2 x plus 2. Cooperation from the computer. Okay. But as you can see, if I type in a negative 1/2 x plus 2, negative 0.5 x plus 2. So there's my line. So therefore, if I'm graphing this, okay, here's my line. Technically, this line should be dashed. Okay. Technically, this line should be dashed. All right. And I thought maybe I had a tool for that, but I don't. But just picture this line being dashed, okay? And we have to shade everything that is greater than. So the half plane that is greater than is all up here. So you would shade this whole top of your graph. So I'm just going to kind of draw that for you. Here's my graph. I know my y-intercept is 2, so I go up 2. Okay, there's a point. My slope is down 1 to the right 2, down 1 to the right 2. Here's another point. As I told you, I have a dashed line. It's not going to be pretty, people. Okay, And I needed to shade everything that is greater than, so it's right up there. Okay? Example 2 says, is the set of points satisfying 3x minus 2y greater than 6 above or below the line with the equation 3x minus 2y is equal to 6? Okay, well, let's find that out. If I solve for y here, okay, I get a negative 2y is greater than 6 minus 3x. Okay, I just moved my 3x over. And then I divide by a negative 2. And if you remember, when you divide by a negative number, you have to flip the inequality sign. So y is now less than a negative 3 plus 3 halves x. So this is going to tell us what has to happen. Because this line is just this line but equals, right? So it lies right on top of it. They want to know, are you supposed to shade above or below that line? Well, since I solved for y and remembered my little inequality deal that if I divide by a negative number, I know I have to shade below. Remember, always read from the variable. Y is less than a negative 3 plus 3 halves x. Okay? Lattice points. In the examples you have seen, the domain of all variables is the set of real numbers or a subset of real numbers. In these cases, the graph of an inequality consists of all points in a region, indicated by shading. However, in some situations, the domain of each variable is a discrete set. Okay, if you remember our discrete sets, you can buy 1, 2, 3, 4, 5 pencils. You cannot buy 1.5 pencils, 1 1/3 pencils, so on and so forth, such as a set of integers. In these cases, the solution set consists of points whose coordinates are both integers, and these points are called lattice points. Okay? If there are not too many lattice point solutions, you should indicate each with a dot on the plane rather than shading an entire region. Okay? Now, I don't get too quirked up in your lattice points, but the book does want me to show you, and there is a problem like this on your test. However, if you just shade it, okay, I am fine with that. So if you look at example 3, it says, Aletta wants to buy P pencils at 12 cents each and R erasers at 15 cents each and spend no more than $1. Okay? What combinations P, R are possible? So we're going to put these in cents. So 12 cents, I'm not going to put a decimal on it. I'm just going to put 12 times P plus R erasers at 15 cents, so it's 15 times R, has to equal, and a dollar has how many cents? Well, it has 100 cents. Okay, so if we were going to do this by ourselves, we would need to pick one X, one Y, and they did it here for us. They picked R as your Y, P as your X. So we're going to solve for R, which means we got to subtract P, so it's 15R equals 100 minus 12P. And if you divide by 15 on each of these, okay, R is going to equal 100 divided by 15 equals 6 2/3. We make that a fraction. 20 over 3. Minus, and this is going to reduce down to 3 can go into both those, so 4/5 P Okay, so as you can see here, 20 thirds, they got that graphed. Okay, and we needed this to be less than, I guess, 100 instead of equal to 100, because all this has to be less than 100 cents because we can't go over 100 cents. So this has to be less than as well. Okay, so if we were to graph that, here's a point, we did our deal, got another point, and we made our dashed line. Okay, what the book wants you to do is obviously make the lattice points that fall in there. So can you buy 0, 0 of each? Yeah, and you'll have 100 cents left. Can you buy just one? One eraser? Yeah. Can you buy just 2 erasers? Yeah. 3, 4, 5, 6, etc., etc. Can you buy just one? Yeah. What they're saying is you really shouldn't shade in the whole thing because your discrete set limits you from that. But like I said, on your quiz or on your test, I'm fine with you shading in this whole thing. We will understand or know that you can't buy 5 1/3 erasers. Okay? That's all I have for you today. Please enjoy. We'll see you tomorrow.